What is gravity? What is the difference between mass and weight? How do mass and distance affect the force of gravity? How does gravity affect objects that are dropped or thrown? How does gravity explain the motion of satellites? The words to know, the vocabulary that you should be familiar with includes gravity, mass, weight, air resistance, free fall, terminal velocity, universal law of gravitation, satellite. What is gravity? Well, gravity is an attractive force between any two objects that have mass. And that includes any two objects. Any two objects. It could be a pencil, it could be you, it could be a planet, it could be another planet, a star, a galaxy. Any two objects that have mass have a gravitational attraction between them. If you drop something, it falls towards Earth because both that object and the Earth have mass, and they pull towards each other. So you're standing on the Earth, you're being pulled towards the Earth because you have mass and the Earth has mass. So not only are you being pulled towards the Earth, but the Earth is being pulled towards you. And this explains why we have round, spherical planets and stars, and a lot of the other celestial objects are spheres because gravity is pulling equally from all sides. It's very important when you know the difference between mass and weight. They're similar yet different. Weight is a measure of the pull of gravity on mass. So weight changes as the pull of gravity changes. Consider your mass and weight on other planets. Your weight may change, but your mass stays the same. So here, if you were 100 pounds, your mass in kilograms stays the same regardless of where you are. But your weight will change. So you can be weightless in outer space, but you can't be massless. How do mass and distance affect the force of gravity? The closer things are, the greater the force of gravity. And the greater the mass is, the greater the force of gravity. So massive things like the sun have a lot of gravity. They can pull at great distances because they have such great mass. The closer things are, the greater the force of gravity. The greater the mass is, the greater the force of gravity. So the gravity between the moon and the Earth is great because they both have mass, they're very massive, and they're very close. So tides are caused by the moon, but not by Mars. Because Mars, though it's massive, is very far away. The sun, though, is far away, but it's very massive. So that has an effect on our tides. And we're in orbit around the sun because of gravity. So gravity is affected by two things, mass and distance. And the greater the mass, the greater the force of gravity. So how does gravity affect objects that are dropped or thrown? Well, within a gravity field, all objects accelerate at the same rate. On Earth, objects fall at 9.8 meters per second squared. The rate of fall is the same for all objects of all masses. A bowling ball will fall just as fast, just at the same rate as a tennis ball. It's the same regardless of how much mass it has. Let's take a look at an example.
Well, in my left hand I have a feather. In my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
So the gravity on the moon is less than that on the Earth because it has less mass. So it's not pulling as hard, so things don't fall as fast. And there's no air. Now, some objects fall faster than others on Earth a lot of times because of air resistance, drag. And this is a type of friction experienced when moving through air. So if we dropped a hammer and feather here on Earth, right, there's air, and air will make that hammer seem to fall at a faster rate than the feather. But that's just because they're air. If we drop them where there's no air, like on the moon, they fall at the same rate. Now, if things are falling for a while, they'll reach what's called a terminal velocity, and this is where the force of the friction of the air is equal to the force of the weight pulling down on the object. And so it stops accelerating and it travels at the same velocity, as indicated by these diagrams here. Now, it's also not apparent all the time is that when you throw something horizontally, it'll also fall at the same rate as something that's dropped. So if I take a sphere like here and we drop it and we throw something else sideways, they will fall at the same rate because gravity is still accelerating them at the same rate. It doesn't matter if you throw it sideways or not. It would be different if you threw it upwards any amount because you're showing that it's going to be going another direction, up, before it goes straight down. But if it's dropped at the same time, one horizontally and one straight down, they're going to hit the ground at the same time. How does gravity explain the motion of satellites? Well, man-made satellites, the moon, planets, everything that orbits around something else due to gravity. And this explains the orbit of the planets, the moon, all the man-made satellites we have. And it's amazing to think that Sir Isaac Newton thought of this way before there were any man-made satellites. So before him, there was really no explanation for why the planets behaved the way they did. They had some ideas, but there really was no concrete way of knowing what it is mathematically that made the planets move around the sun the way they do, or the way our moon moves around the Earth. And he explained everything through the universal law of gravitation, which you saw earlier. And he also explained how it would be possible to make a man-made satellite. In this drawing here, he had the thought experiment of thinking of a cannon on the top of a large mountain. And if you put more and more gunpowder, what would happen? Well, eventually you would shoot it with such a great amount of force that you would be able to get escape velocity, and it would begin to orbit the Earth because its fall would equal the curvature of the Earth. And so he predicted making man-made satellites before it was even possible. And that's just amazing. And that's science. That's cool. Well, that's it for gravity. Make sure you review this, and good luck with the questions.